Now sharing with you the another worksheet of ionic compound and their properties. Question number 1 is show by using dot and cross diagram the bonding in these ionic compounds. These are the ionic compounds and you have to show the dot and cross structure in their bonding. So in a dot and cross structure you have to show the electrons of one atom with the dots and the electrons of another atom with the cross. So in a calcium chloride, this is ionic compound. First you have to draw the structure of calcium. First shell having 2 electrons, so you have to show with the dots. Second shell having 8 electrons, so show with the dots. Here 8 electrons. And third shell having 8 electrons. So again show with the dots. You have to draw it with properly with the dots, 8 electrons. In the next shell, there are 2 electrons, but when there is ionic bonding, calcium lose its 2 electrons, so it will contain 2 plus charge. So no need to write the fourth shell. Next, we have to draw the structure for chloride. So show the electrons of the chloride ion with the cross. 1 electron, 2 electron, 2 electrons in first shell, then 8 electrons in next shell, in second shell. So you have to show it with the cross. So you have to show the electrons with the cross. One atom's electrons with the dots and another atom's electrons with the cross. And the third shell contains 8 electrons. In neutral atom there are 7 electrons, but when chlorine gain 1 electron, it becomes chloride ion and contains 8 electrons in an outermost shell and 2 negative charge due to that 2. Clear? So in this way you have to draw the structure of all these ionic compounds. For example, sodium sulfide, sodium having a 1 plus valency and sulfide having 2 minus. So in this way you have to write it like this Na2S. So 2 atoms of sodium and 1 atom of sulfide. So write 2 with the bracket of sodium. So you have to draw the structure of sodium with the dots and structure of sulfide here with the cross. In this way you have to draw the dot and cross structure of all these ionic compounds. Next question we having that is cesium is an element in group 1 of the periodic table. As we know, cesium belongs to the group periodic table in a group number 1 it exists. As we know, lithium, sodium, potassium, rubidium, cesium, francium, these all are the elements of group number 1 of the periodic table. So how many electrons has it in its outermost shell? As we know, the elements belong to the group. That specific number of the group is showing the number of electrons in their valence shell. So if it belongs to group number 1, so that group number 1 shows it having 1 electron in its outermost shell. Write the formula of its chloride. So cesium belongs to group number 1, so which shows it having a valency +1 because the metals having a valency plus. Second is chloride. Chloride having a valency 1 minus. So no need to add the atoms because both having the valency 1. So in this way they will make a cesium chloride compound. Third one is also the same one, so ignore this. D part of question number 2 is write the formula of its oxide. So cesium for oxide you have to write oxygen. Oxygen having a valency 2 minus and cesium having +1. So you have to cross exchange. So you have to take 2 atoms of cesium to make it a neutral ionic compound. In this way it becomes 2 plus 2 minus, so they will cancel out their valencies and become neutral ionic compound. The last one is comment on its reactivity. So cesium is basically belongs from the group 1 and group 1 elements are the alkali metals. They are reactive towards the non-metals. They lose their electrons and make ionic bonds with the non-metals, and cesium is a metal, so they having a metallic bonding also. So show their reactivity according to their presence in group number 1. They having a high melting and a boiling point. So in this way you have to show their reactivity. Next, question number 3. Question number 3 is element X and element Y combine together and form ionic compound, that is XY. This XY is showing that both the element having same valency. It's possible that both having a valency +1 and a -1, and both having a valency 2 plus or 2 minus. So both having the same valency, that's why they are exist as a single atom. They are combined as a single atom. So option number D is the correct one. X is having atomic number 12 and Y having atomic number 16. You have to check it out, because if the X having atomic number 12, so first shell having 2 electrons, second shell having 8 electron, and third shell having 2 electron. So in 16 atomic number element, first shell having 2 electrons, second shell having 8 electron, and third shell having 6 electrons. So this Y element needs 2 electrons, and this X element need to donate its 2 electrons to complete its octet, and Y needs 2 electrons to complete its octet. Contains 8 electrons in its outermost shell. So this X will lose its 2 electrons and becomes 2 plus, and this Y will take these 2 electrons and becomes 2 minus. In this way, both having the same valencies, so both combine with each other as a single atom. X will donate its 2 electron and Y gain those 2 electrons. So D option is C. You have to check it out by all these ABC. You check out their electronic configuration in shells and then compare that they can make bond as a single atom or not. Next question is question number 4. Which substance in the table is an ionic compound? This is a table and you have to show that which one is an ionic compound. As we know, ionic compounds are formed by the combination of metals and non-metals, and ionic compounds are solids in nature. Their state at room temperature is solid. So first is not considered as a correct, B is not considered as a correct, C or D could be considered as a correct one. So see the second thing, electrical conductivity at room temperature, is it good or a bad? Their electrical conductivity is not good at room temperature. So this will not be the correct one. Their conductivity is poor at room temperature. Second thing is electrical conductivity of aqueous solution is good. This one is also the correct. Ionic compounds are solid at room temperature. They do not conduct electricity. They only conduct electricity in aqueous solution or in molten form. So C is also not correct. The D option is the correct one. So you have to think about the question in this manner, that which are the properties of the liquids and the solid, what are their nature, what their conductivity, what are their characteristics. On the basis of these all things, you have to choose the best possible option. Question number 5. Fluorine, chlorine, bromine, iodine are elements in group 7 of the periodic table. As we know, these all are halogens. Scientists are trying to synthesize new elements in group 7 with the proton number 117. So elements are trying to discover this element. That they are thinking that this element is belong to group number 7. So keep in your mind that this element belongs to group number 7. Now answer these questions. How many valence electrons will be present in one atom of this element? In this element, how many number of electrons in valence shell? 7 electrons, because halogens having 7 electrons in their outermost shell. So in the same way, if this new element is belong to the group number 7 of the periodic table, so it will also have a 7 electron in its outermost shell. Complete the following table about an isotope of this new element. As we know, this is a proton number 107, so you have to write here the number of proton 117. How you can calculate the number of neutrons? If you are going to subtract the subtract the proton number from the nucleon number, you will get the number of neutrons, because nucleon number is basically the mass number and the mass number is the sum of the protons and the neutron. So if you subtract the number of protons from the nucleon number, you will get the number of neutrons. Question number 5, part C. Let's discuss here. Predict two physical properties of this new element. So if they are saying that this new element, it belongs to group number 7, it belongs to halogens. So we know halogens are non-metal. So this new element will be non-metal. Non-metals having a very low melting and a boiling point, and they are not a good conductor of electricity and heat. So these could be the predictive properties for this new element. Next is D. Fluorine react with magnesium. Fluorine react with magnesium to form magnesium chloride, MgCl2. Product will be MgCl2 because magnesium having a 2 plus valency and chloride having a 1. So balance this ionic compound, we need two chlorine atoms. So MgCl2, sorry, MgF2. This is the wrong. Let's write again. Fluorine plus Mg, not magnesium chloride, is magnesium fluoride. So it will be MgF2. Magnesium having 2 plus valency and fluoride having minus 1. So to balance this ionic compound, need 2 atoms of fluorine. So it becomes magnesium fluoride. So in this way, you can write the balanced chemical equation. Fluorine not exist as a single atom, so you have to balance it by writing here 2, because fluorine exists as a molecule, F2. Chlorine exists as a molecule, Cl2. Bromine exists as a molecule, Br2. So in this way you have to write here F2. So fluorine gas reacts with the magnesium and it becomes magnesium fluoride. Next is give both the electronic configuration and the charge on the ions which are present in magnesium fluoride. So in same way as we did for calcium chloride, magnesium having atomic number 12. So first shell having 2 electrons and the second shell will have 8 electrons. It becomes 10. I'm not going to write the left 2 electrons because those 2 electrons are donated by the lost by the magnesium atom to make an ionic compound with the fluoride. So I am going to write here 2 plus ion. It becomes ion by the loss of 2 electrons. Next we have to write for a fluorine. Fluorine having atomic number 9. So first shell having 2 electrons and the second shell having 7 electrons. When it takes 1 electron from this magnesium, each fluorine atom will take the 1 electron. There are 2 fluorine atoms, so each fluorine atom take 1 electron and become fluoride ion. So 2 fluoride ion will be formed. In this way it becomes 2 minus. So first shell having 2 electrons and the second shell will have now 8 electrons. So in this way magnesium fluoride ionic compound is formed. Next is question number 6. Here you can see the question number 6. Okay. Complete the sodium fluoride lattice by inserting orange dot for the sodium ion and the green for the fluoride ion. In a lattice structure, we know that alternate corners are taken by the opposite ions. So for example, this is the sodium ion, positive ion, this one will be the negative ion, fluoride ion. This one again will be the sodium ion and this side contains the fluoride ion. This will contain the sodium ion, this will contain the fluoride ion. So each corner is taken by the opposite ions. If this is a fluoride, so this corner will be taken by the sodium ion. This is a sodium, so this will be the fluoride ion. So in this way, all the corners of the lattice are taken in ionic compounds. Sodium fluoride and magnesium oxide have the same crystal shape. Their crystals having a same shape because they having a same atomic ratio. One atom of sodium, one atom of magnesium, one atom of fluoride, one atom of oxygen. So both having the same atomic ratio. 1:1. One atom of sodium, one atom of fluorine. One atom of magnesium, one atom of oxygen. So ratio is 1:1. So both having the same ratio. That's why they having the same crystalline shape. So they having the same crystal, but they having different melting point. Here you can see sodium having a 992 degrees Celsius melting point and magnesium oxide having a 2640 degrees Celsius. Why magnesium oxide having a high melting point? Because in a magnesium oxide there is a complete transfer of 2 electrons. Magnesium will transfer 2 electrons and oxygen will take those 2 electrons. So by the transfer of 2 electrons, there is a very strong bonding between magnesium oxide. Instead of sodium, there is a transfer of 1 electron from the sodium and gain of 1 electron by the fluoride ion. So they having a weak bonding as compared to magnesium oxide. That's why sodium fluoride having a less melting point and magnesium oxide having a high melting point. You need a high energy to melt the magnesium oxide. Last question is, this is from your textbook. Deduce which of the following ionic compounds could have an ionic lattice as shown above. So you can see here A and C both having one atom attached with each other. So all both ionic compounds, those having same valences, could contain this lattice structure. So you have to choose from all these. Magnesium oxide having same atomic ratio MgO, so it could be this lattice structure. Potassium sulfide, as you know, K2S, so there is not a same atomic ratio. There are 2 atoms of potassium, but in this lattice structure you can see one atom of metal and one atom of non-metal is attached. Then one atom of metal and another non-metal. So alternate single atoms are attached with each other. So this will be the wrong one. Sodium fluoride, yes, sodium fluoride both are single atoms. So it could be sodium fluoride, it could be magnesium oxide. In a calcium bromide, there are CaF bromide. This is bromide, CaBr2, because calcium having a 2 plus valency and bromide having a minus. So that's why here too. So this will not be the answer. So in this way, you have to choose that which ionic compounds having this lattice structure. So now you can answer these questions and you have to correct your assignment by my instructions.